Welcome back. Sometimes when creating an inherited class, you want to create a method that calls the superclasses method, but just does a little bit extra. Now, let me explain an example. So let's suppose that I have this pet class, and inside of this pet class, I have a method feed. Now, suppose that I wanted to create something that inherited from the pet class. Let's suppose that I wanted to create a class dog. So I'm just going to draw out the beginnings of that class dog. And I want it to inherit from pet, so I'll say pet in parentheses. Now let's suppose that whenever I fed my dog, I wanted it to both call this feed method, but then let's suppose that every dog instance also has a little extra message. So let's suppose that a dog says arf, thanks, whenever fed is called on that dog. So if I did def feed with self, if I did this, and then let's say that I print out arf, thanks. So if I define my dog class this way, whenever I create a new instance of dog and then call feed on that dog, then all that happens is arf thanks gets printed out. Because when I define this feed method, I'm overwriting the feed method in the parent class. So this would never get called. At least not by default, but there is a way to call it. So the way to call the feed method for this pet class, in addition to printing out this little extra bit of code that I wanted to run, the way that I would do that is I would say pet, capital P pet, so the name of the class, and then I would say dot feed, and I would call this on self. Now, notice that this is calling feed on the pet class. Normally when we call feed, we create a new instance, so I might say d1 equals a new dog. And normally I would say d1 dot feed. And I would pass in no arguments here because d1 is an instance. Here instead, I'm saying the name of the class directly, so I'm saying pet.feed. And since I haven't specified what instance to feed on, and since I haven't specified which pet instance I'm calling feed on, then I need to pass in the particular instance as the first argument to pet.feed. If I tried to say something like self.feed, here, then self.feed is just going to refer to the dog's feed method. So again, the way that I'll create a feed method on a subclass that has everything that the superclass's feed method has and more, I'll call the superclass's feed method by saying the name of the superclass, in this case pet, and then I'll say whatever method I want to call, and then I'll pass in the instance directly. So in code, this is what that might look like. So here I have a dog class, and the dog class inherits from pet, but it has its own feed method. Inside of that feed method, I first call pet.feed with whatever instance this feed method is being called on, and then I print out arf thanks after the pet.feed method has been called. Now, this also works for constructors. So let's suppose that I have another subclass of pet called bird. And let's suppose that the bird class has its own constructor, but I want to call the pet class's constructor as well. Well, the way that I would do that is I would say pet._init, and I would call it with whatever arguments I want to call. So in this case, I'll pass in self, and then I'll pass in the name. And what this is going to do is it's going to call the pet class's constructor on this new instance of bird. So it's going to set name, hunger, boredom, and sounds. So let's do some multiple choice questions. Okay, so this question asks, what would print when printout b1.sounds is run? So b1 here is an instance of bird. And if I'm calling b1.sounds, then you'll see that that's an instance variable that gets set right here. So here we're setting self.sounds equal to a copy of self.sounds. By default, every pet has a sounds list of MERP. You'll see that the bird class has a class variable sounds set to chirp. So when I call pet._init, when it sets self.sounds equal to self.sounds, a copy of self.sounds, what that's going to do, because B1 is a bird, is it's going to create a copy of this list of sounds. And so B1.sounds ends up being chirp. So again, the reason that it's creating a copy of this list of sounds is because we have the superclass pet then we have a subclass bird, so every bird is a pet, and then we have an instance of bird, and that instance is called B1. Bird has its own value for sounds, and pet has its own different value for sounds. Now, when we say b1.sounds or self.sounds in the constructor equals a copy of self.sounds, then Python is going to first look for what is the value of self.sounds. So let's go back to the constructor. So when we said self.sounds, here again, self is b1. So we're setting self b1.sounds equal to b1.sounds, and we're slicing it so that we create a copy of b1.sounds. When Python is searching for b1.sounds here, it first searches inside of the instance. This instance doesn't have a sounds instance variable yet, and then it searches inside of that instance's class, and so we find chirp, or a list that only contains chirp, as the list of sounds, and so here we end up creating a copy of that. So I mentioned all of that just to say that the answer to this is C. Or let's do another question. This question asks, for the dog class defined in the earlier window, what would happen when d1.feed is run if the pet.feed self line was deleted? So in other words, if we deleted or commented out this line, then what would happen when we called d1, which is a new instance of dog? What would happen if we called d1.feed? Well, so if this pet.feed self line was deleted, then the only thing in the dog feed method that actually runs is this print statement, print arf thanks. So remember that the pet feed method is never called by default because this method overrides that method entirely. So the only thing that would happen is print arf thanks would run. So that means that the answer here is C. That's all for now. Until next time.